Okay, so thank you. Well, I'm very happy that this session today allows me to. I'm happy that this session explicitly allows me to focus on the possibilities, the challenges, and the limitations of our methods, because that's the thing you really do. Usually you talk about your results. Talking about the limitations seems a little boring and tiring, but it's worth to be mentioned every now and then and to be kept in mind. So the objects of our study are the remains of historic charcoal hearths or charcoal piles, charcoal kilns, different terms in different regions. Here are some charcoal burners operating charcoal hearths on a flat landscape, and here are the characteristic remains of such sites. So there is charcoal-rich sediment, typically 20 to 40 centimeters, added to the top of the natural soil profile. And there is also a characteristic landform associated with these charcoal hearth remains. In the flat landscape, that's a slightly elevated platform, which is, as you can see, quite hard to see when walking through the forest, even harder on a photograph. But when we look at digital elevation models with a resolution of 1 meter or 2 meters, you can quite clearly see all these structures, so a lot of such sites in many, many forest areas. And that's also the reason why, with the growing availability of such elevation models, more and more studies came up during the last years in more and more regions documenting huge numbers, thousands, tens of thousands of such sites in different forest areas. We heard about the Białowieża forest before. There are also recent studies from Silesia reporting huge densities of soil. And as all these studies are coming up, we can start comparing numbers, densities, distribution patterns between the regions. But as we do this, we have to keep in mind what we actually see from these elevation models and what we don't see and cannot map. So we've done a lot of mapping in different regions through the last years. We are still fascinated about all the things we can see in the models, but we also getting more and more aware of what we don't. And I'd like to share some of this experience for several study regions. So our work started in Brandenburg, Northeastern Germany, in the forefield of the open-cast lignite mine in Schwalde, where archaeological rescue excavations documented a large number of charcoal remains. We have worked, so accompanying these excavations by doing surveys from remote sensing data, and of course we have an exceptionally good ground truthing situation and exceptionally good possibilities for evaluating the remote sensing results here. We then extended this work first to the surrounding of an historic ironwork and mapped in all the forest areas that were situated around this ironwork, and then extended the mapping to the whole state of Brandenburg, all the forest areas here. So here we typically have these elevated platform type sites. Here's a ground plan, and here's the same site in the elevation model. We have a relatively simple, homogeneous background situation here. So we have flat topography in Brandenburg. Most of these sites are situated on similar soils, sandy soils, because the forest areas are just located on these sandy soils in the region. Also, the historic industry, as the most important consumer of charcoal, is relatively easy to capture, because in the Prussian state, iron production was very much focused to a few large ironworks, which are relatively well described. To make it a little bit more challenging, we moved to another study area that's in Upper Palatinate or north in Bavaria, where we have a very, very long history of iron production with many, many small ironworks dating back to the Middle Ages or even further back, operating over different periods and not so well documented, obviously. We also have a more heterogeneous morphology and geology, and we have different types of charcoal earth remains. So here are the two most common examples, also similar as those we've seen before on flat landscapes, but also many sites on sloped terrains where we have small level platforms on slopes. We also moved to a study region in the northeastern USA, where we also have quite heterogeneous surface morphology, but we have a very well-defined history of charcoal and iron production. So iron production began only in the 18th century. They peaked in the middle of the 19th century and came to an end shortly afterwards. And what's characteristic for this region is we also have, I hope you can see anything here, these slope platform types of charcoal earth remains. But they are very well preserved because they mainly are clearly delineated with stone walls around the site. So they are relatively easy to see. So here are some first results of relatively small scale ground truthing. That's an area in the mine field. It's a pine forest. And we used a digital elevation model provided by the mining company with around 4 ground points per square meter here. We did a first round of mapping where where one mapper marked really every location which might potentially be our site. And we did a second round of mapping where 3 mappers worked together to really only map those sites that were actually considered to be of earth remain. In this first round, we saw that also we got a lot of sites, a lot of false positives. We only captured around 70%. So even if you mark everything you see, there's a certain number of sites you cannot map from the elevation models because they are too small, they are leveled by subsequent land use, something like this. In this other round of mapping, sensitivity is slightly lower, but with considerably lower number of false positives. We saw a very small bias, so we captured more of the large sites, but as you can see, so the white dots are sites we did not capture here. There are also large sites which we could not capture, more smaller ones, but also large. Here is another part of the region that's the same elevation model. The only difference is that we have not pine forest, but oak forest here with denser undergrowth. We did a field survey for ground truthing here by walking the whole area. And mapping sensitivity is considerably lower than before. So although we have DEM with 4 points per square kilometer, same flight, same processing here, we see a difference between different areas, most probably mainly related to different vegetation cover, also resulting in different DEM quality. We did this again here with a higher resolution DEM, which looks very, very good and seems to capture almost all the structures. Still, there are about 25% of that you miss. Here's one example for the Northern Bavaria study site. We used older field survey from the 1970s here for ground truthing and compared our SRM mapping results to this. And what we focused on here is to compare between different geology and different substrates, because we thought maybe there's a difference in preservation of sites between substrates. we see that we slightly underestimate sites in some geological units, slightly overestimate them in others. The total sensitivity is quite low here, only 40%. That's the elevation model. Also 1 meter provided by the Topographical Survey of Bavaria. In this area, they only have at least 1 point per square meter. And if we look at the variation within the survey area, we see that we have quite good results, mainly in the slope areas or the higher areas. And it's very hard to see any structures, especially in the lowest areas of the site situated on alluvial deposits and close to the wetlands. We also see when we have a close look at this DEM that we definitely do not have 1 ground point per square meter everywhere. So there's a variation of EM quality on a very small scale within the area. Also related to vegetation, with vegetation structures in these wet, low areas, we have denser vegetation. For the Northeastern USA study site, that is again is a DEM with at least 4 points per square meter. Mapping quality was surprisingly good, which is most probably related to this very well formed sites, the stone walls that just have a clear signature in DEM. Although we have relatively unfavorable conditions with dense, broadleaf vegetation cover, rocks on the surface, and so on. Nonetheless, these sites can be captured very well. So there is a lot of small-scale variation in mapping quality that you don't immediately see from the basic parameters of the DEM. We then went to the larger scale, keeping in mind that we capture at least around 50% of our sites. That's site density for the whole state of Brandenburg. Here is the same map with forest areas in the background and with the industry sites. I'll try to guide you through this in the next slides. We have several areas where we have clearly defined charcoal production fields, well related to historic industry sites. We also have areas that are not related to historic industry, but you can relate this and also this to charcoal consumption by the city of Berlin. So here are waterways going to Berlin. Then we have a few areas where we have large, very important iron industry consuming a lot of charcoal, but we map a surprisingly low number of sites. If we have a closer look at this, we see that we have surface disturbance in several areas. We have military training areas in a lot of regions in Brandenburg. And as you can see here, it's practically impossible to map anything in these areas. We also have many open cast mines that, of course, completely destroy the surface. And we have areas with low DEM quality, which we cannot relate to the basic parameters of the DEM, the year of the flight or something like this. It's just observable from a close visual observation of the elevation model. So all in all, you can see that it's quite a large fraction of the forest areas where we have a low mapping quality because of different kinds of surface disturbance. When we go back to the Northern Bavaria study area, similarly we see several clusters of densities. Some of them are clearly related to iron industry, mainly to those ironworks operating for a long time until modern times. We have areas like this one that are not related to industry. That's the same situation a similar situation as seen before for Berlin. This is south of Nuremberg, where we just have the big city with small industry as an important charcoal consumer. if we go to those areas that were the centers of the early medieval or medieval to early modern iron production, there are two river courses, a lot of ironworks, iron towers here. Charcoal hearth densities are relatively low again. If we start looking for reasons for this, again, we have some areas with low DM quality, some areas with military training sites, but not exactly in these areas where we would expect more charcoal production than we can see from mapping. So I only can show some potential reasons for this. We looked at geology because, for example, down here, we thought that results might be related to the fact that sites are not very well preserved or have a different morphology in this geological unit. So that's Jurassic limestone all over here, all the bluish colors. We have different kinds of sedimentary rocks here, and we have granite and quartz bedrock in this area. However, we see that we have a lot of sites also in this Jurassic limestone, so geology is not one reason that can simply be captured from a map. If we look about geology and elevation, we can see some more reasons for these different densities. For example, if we look at this very, very large cluster of sites south of Nuremberg, we have a very flat landscape here, and we have the same type of charcoal hearth as described for Brandenburg. So on a flat landscape, just pile of wood piled up without any large preparation of the surface before. So all these sites have probably been used only once, or for several times within a short time period. When we go to the slope areas and look at the soil profiles, the stratigraphy, we clearly see that these sites have been used over and over again. So of course you have lower site density in such areas. And then we have some uncommon types of charcoal hearth remains like this ones, which have a kind of a ring wall around the site. And from what we know from our field surveys up to now, these sites seem to have been used very, very often, maybe over centuries. So, of course, when sites are used for many times, we have lower densities in the end. And we need to keep in mind all these different practices of charcoal production when we interpret the spatial distribution of sites. Just some more background information. These are parts of the mapping campaign in Bavaria from the 19th century, so maps from around 1840. And we see that especially in these regions with the old iron hammers, we very often have hearth sites that are situated directly close to the ironworks. So charcoal was not produced in the forest, but wood was transported to the iron hammer and charcoal was produced there. And of course, we cannot map this now because these are now mainly settled urban areas and are destroyed. So, to sum up, we see that these legacies of charcoal production occur in very many forest areas, in vicinity to historic industry sites, but also in other areas. We see that we have a heterogeneity of mapping quality, both on small scale, related to DM quality, which is in turn to a large part related to vegetation cover. And it would be very good to always have actual spatially distributed map with ground point density in the background when you do such a mapping. Unfortunately, this is usually not provided, even when you buy an elevation model. So you would have to analyze point clouds yourself to get this. You hardly can do this. We also have heterogeneity of mapping quality on the larger scale, mainly related to surface disturbances by subsequent land use, which we have to somehow capture from background information and to keep in mind. And we have varying site densities related to the cultural background, to the way of charcoal production, to the way of using forests, and so on, which we have to assess from background information from archives to really be able to analyze such distribution patterns. And all these small scale and large scale variations need to be kept in mind. So that's the key message. Thank you for your attention.